Hello everyone. Our names are Reydesel Rangel.
Jason Ramirez.
Michael Perez.
And Hozbaldo Silva.
Today we will be explaining our program created for our prospective NAE Grand Challenge topic, which is access to clean water. The data set we have chosen to analyze represents the percentages of the populations in respective locations around the world that have availability to clean water. Lack of access to clean water in many third world countries is an issue that has been ongoing for many years. The purpose of our program is to allow the user to see clearly what locations around the world need more access to clean water by comparing them with other locations in the year selected. The program should also allow the user to calculate how much of a location's population will have access to clean water the following year based on the user's input.
By displaying our information on a global scale, we are able to show the water crisis occurring at different locations at certain years. It allows us to shine the light on the location that lacks access to clean water in an attempt to, hopefully, in the future, provide aid to that region. In our program, we can demonstrate the projections of the upcoming year through trend lines, which depends on the user input. By displaying this, we can show, if aided, how much a location can improve in the percentage of people that have access to clean water.
The algorithm we used to complete this program had various steps. The ones found on our poster, which are the 5 on the bottom right, those are the 5 most important steps that allow the user to output the results that we want the program to do. After doing the usual housekeeping commands and then loading the data provided, we validated the data, and then after that we found the size of the data which provided the rows and columns of it. After doing that, we removed any location that didn't have any data, since that would be conflicting when outputting the results. Once that was done, we made sure that the rows of the data and the number of locations were exactly the same, or else again, it would cause conflict at the end when outputting. Once that was done, we allowed the user to select one location by prompting a list, and then we allowed the users to select a second location, and after doing that, we allowed the user to select a year for them to compare those 2 locations. If the user were to not click any location or year, the program would automatically stop. We then use a while loop to validate the data that the user has selected. Once the data has been validated, a bar graph will be displayed on the screen comparing both locations in the respective year. Once the user is done seeing the information on the bar graph, they will be asked again if they want to compare 2 different locations in a different year, and that is done by putting a while loop outside of the whole section that was just done. Once the user is done comparing 2 locations in the select year that they want, a new while loop is created which asks the user to select a location to view projections. In that menu, if the user does not make a selection, it will again end the program. Once the user selects a location, a new while loop will be created within that while loop. Inside the while loop, the user will be prompted to enter a projected growth rate. They will be given 3 tries, and after those 3 tries, if they have not entered a value greater than 0, then the program will just take the last value and take its absolute value. Once the projected growth, the growth rate is calculated with the selected location, a data versus years graph will be displayed, and then that will be displayed with 3 different trend lines, which are in a subplot of linear, power, and exponential. Once that is seen by the user, they will be asked to calculate another projected growth rate for the same location if they would like to. If they say yes, then the figure will close and the whole while loop will run again. If they say no, then the user will be given the chance to select another location and rerun the entire program. If they say no to that, then the entire program will be completed, and in the output the user will see the information they need.
So this is how our algorithm looks like in MATLAB. If we run this code,
you'll see that a list of locations has popped up. We can choose 2 locations, so the user will choose Switzerland and Costa Rica. Another menu will pop up that shows the years that the user can select. So if the user selects 2009, a bar graph pops up displaying both locations and the percentages of the population that has access to clean water. In this comparison, Switzerland has a higher percentage. Another menu pops up over here that asks the user if they want to compare another 2 sets of locations. So if I say yes, we can choose any other location, so Estonia, Belarus. Another set of years pop up and a different bar graph appears. So if the menu doesn't want to compare another set of locations, it'll output another list, but this list is for the next section of our code, which is the projections. So let's say the user wants to look at Ireland. Our command window will now pop up and it displays the percentages that we had already selected for the 2 comparisons previously, and we have an input. So let's say the user inputs 2%. These 3 trend lines appear, and we have a linear, an exponential, and a power trend line. And another menu pops up asking if you want to calculate a different projection for the same location. If we look back into our command window, you'll see that it says the projected growth was greater than 100%, so we assume that it reaches 100%. If we go back to our menu and we say, yes, I want to calculate another projection, let's say, okay, what if it was less than that? What if you go with 0.5? It'll change the output. We see that it did not reach 100%, and so we can continue. Let's say the user wants to look at a different location. They have to say no, and now our code asks the user, would you like to look at another location? We say yes. This time let's choose Ethiopia. It'll ask them again for another projection rate. Let's say 2% again. We'll see another set pops up. This time, let's say no. Let's say no to this, and our code has finally ended. If we go back and run it again, at any point during user selection, if the user decides to exit out or not give an input, it'll give an error. If we run our code again, we get to our projections. We're choosing random countries, a random year. We say no. We'll just choose Albania for now. Our code will give a warning if the user inputs a negative value, and it will give this warning 3 times, and it'll allow them only 3 tries. Once they input the third value, the third negative value, the code will assume the absolute value that they input and continue with the code. And as I said, at any time, if I don't use it or don't input a selection, it should end. But since we ended our code, it stopped there. We run it again, beginning of the selection, gives us an error. If we run the code again, we go all the way back to our projection menu over here, the selection, it'll give us errors. And that is our code.
Some of our limitations are that we only have data ranging from 2000 to 2015. Another limitation is that we had to delete some data from our data set, and this data set that we now have limits us to not including the rest of the countries all over the world. One of the applications of our program is that nonprofit organizations like UNICEF that like to aid third world countries can use this information to help third world countries have access to clean water.